In this video, we will be learning about limits by direct substitution. If a function is continuous at x equals a, then the limit as x approaches a of f of x is equal to f of a. That means we're simply plugging in or substituting whatever the limit is approaching. Let's take a look at the graph of f of x equals x cubed. We can see that this graph is always continuous, and you might already know that all polynomial functions have a domain of all real numbers and are continuous. Graphically, we can determine that the limit as x approaches 2 of f of x is equal to 8. And that's because the left-hand limit and the right-hand limit are equal, and they both equal 8. So let's examine that here. So at 2, we can see from the left, we're approaching the y value of 8. From the right, we're approaching the y value of 8. Therefore, that limit is, in fact, 8. But now we can verify that by doing direct substitution. Since we have this function x cubed, and we now know this information that the limit of as x approaches 2 of f of x is equal to f of 2, if we plug 2 into that function, we will get 2 cubed, or 8. Let's now take a look at f of x equals x squared plus 6x plus 5. This polynomial function is also continuous over the set of real numbers. And we can observe by the graph here that the limit as x approaches -6 is equal to 5 because the left-hand limit and the right-hand limit are both equal and they both equal 5. Okay, so notice here's our left-hand limit, the right-hand limit, they're both approaching +5. We can also verify that by direct substitution. So the limit as x approaches -6 of f of x, plug -6 into the function, so -6 squared plus 6 times -6 plus 5, and that will give us 5 as our answer again. So basically, when we do limits analytically, our first step is always going to be to try direct substitution, meaning whatever the limit is approaching, try plugging it in for x. Okay, let's do some sample problems working with that. Number 1, we're going to find the limit as x approaches 3 of 3x plus 5. Well, we're going to substitute 3 in. We're going to get 9 plus 5, or 14. Number 2, the limit of, as x approaches 7 of x squared plus 4x minus 2. So we're going to plug in, that's equal to 7 squared plus 4 times 7 minus 2. That's 49 plus 28 minus 2. And we are going to get 75 as our limit. Number 3, the limit as x approaches -4 of 2x squared minus 7. That's going to be 2 times -4 squared minus 7. Again, we are simply just substituting whatever x is approaching in for x. Again, direct substitution. We're going to simplify this, so 2 times 16 minus 7, 32 minus 7, or we get 25. Okay, it's not necessary to show all of those steps with the arithmetic there. Number 4, limit as x approaches 9 of radical x is simply radical 9, or 3. Number 5, the limit as x approaches pi of sine of x. So we are going to plug in pi for x here. And now we have to think as to what our answer is. Now, if we have our calculator and we have access to it, sure, we can use our calculator, but we're going to want to check that we're in radian mode. Okay, so I'm going to change mine to radian mode here, and I'm going to type in sine of pi, and I see that I get 0. If we don't have our calculator, we can use our unit circle to help us find that value. So pi is over here. And when you have a coordinate on the unit circle, the x value is the cosine of that angle. The y value is the sine. So we can see the y value at pi is 0, and therefore the sine of pi is 0. Number 6, the limit as x approaches -1, and we have a big polynomial function, so we're just going to plug -1 into each of these. All right, so -1 to the 4th is 1. Then we're going to get plus -1. plus 1, plus -1, plus 1. So we're going to see these are going to go away and give us 0. These will give us 0, and we simply get 1 as our answer. Number 7. The limit as x approaches 5 of x plus 6 times x minus 7. You could distribute and multiply that if you would like to, but you don't have to. You could plug in simply as it is. Okay, so when I plug in here, I'm going to get 11 times -2, or -22. Number 8. The limit as x approaches 0 of cosine 2x. Well, that's going to be the cosine of 2 times 0, which is the cosine of 0, right? Anything times 0 is just 0. And we have the same options as before. We can go to our calculator if we have it, and we can see that that's 1. Or we refer back to our unit circle. 0 is over here. The x-coordinate is the cosine, and we see the x-coordinate is 1. Number 9, the limit as x approaches 3 of e to the x is going to give me e to the third, and I'm going to leave it exactly like that. If I were to type that into my calculator, so if I want to go through this and do e to the third power, we're going to get a long decimal here that would keep going on. It doesn't give us any information about rounding, so I'm going to leave my answer exact as e cubed. Number 10. The limit as x approaches 2 of x cubed minus x squared plus 7. You can see I'm substituting 2 in for each of the x's. So this is 8 minus 4 plus 7. And that will give us 11 as our answer. All right, number 11, the limit as x approaches 1 of 5x squared plus 4 over 2. We're going to substitute. The numerator is going to give us 5 plus 4, or 9 over 2. And I'm going to leave my answer like that. 4.5 is also acceptable. And for our last problem, the limit as x approaches 6 of log base 4 of 2x plus 4. So we have to remember our log rules here. But first, I'm going to substitute. So this is really log base 4 of 16. We're trying to figure out what that's equal to, right? That's our goal here. So this is basically saying if I convert this to exponential form, 4 to what power gives us 16, and you'll see that we will get 2 when we do this. So this over here is just kind of my side way of thinking about what that actually represents. Or of course, you could use your calculator to do that. So again, when evaluating a limit analytically, your first step is always to try direct substitution. The next video in this playlist is going to show you how to do direct substitution, but also how to add in some algebraic manipulation.